A circular linked list is a variation of the ordinary singly linked list, in which the last node points back to the first node, forming a closed loop. A circular linked list is a variation of the ordinary singly linked list, in which the last node points back to the first node, forming a closed loop. Imagine a chain of paper clips where each clip holds the next one, and the final clip loops around to hold the first. In a data structure, each element, called a node, contains a value and a reference, often called a pointer, to the next node. The most fundamental operation on a circular linked list is traversal. Starting at any node, you follow the next reference repeatedly. Because the list has no null reference to signal the end, you must decide on a stopping condition. The usual technique is to remember the node where you began and stop when you encounter that same node again. For example, to print all values, you store the head node in a temporary variable, then enter a loop that prints the current node's value and moves to the next node. After each move, you compare the current node to the stored head. When they match, the loop terminates. This method ensures that you visit each node exactly once, regardless of where you started. Insertion in a circular list can be performed at the front, at the end, or at an arbitrary position. Inserting at the front requires creating a new node, setting its next reference to the current head, and then locating the last node to update its next reference to the new node. The new node then becomes the new head. Inserting at the end is slightly simpler. You locate the node whose next reference points to the head, set that node's next reference to the new node, and set the new node's next reference to the head. Inserting in the middle follows the same pattern as in a singly linked list. Traverse to the node after which the new node should appear, adjust the new node's next reference, and then adjust the predecessor's next reference. Deletion mirrors insertion. To delete the head node, you must find the last node, set its next reference to the second node, and then move the head pointer to that second node. Deleting any other node involves locating the predecessor, linking the predecessor's next reference to the node after the one being removed, and then allowing the removed node to be reclaimed by the memory manager.